Hello aspirants, welcome to SaaSFlow. This is Shivajanala. Today we will understand the concept of memoization in JavaScript. So memoization technique is to improve performance by catching the results of expensive function calls and returning the catched result when the same input occurs again. That means there is an expensive function call we have and we will store the result when the input is same, and again that function call is being happened in the function, then it will give the result from the cache. That means a faster response will come. This will tell do the work once and use the result many times. First of all, I want to explain the problems without memoization, which we see generally. So without memoization, the function performs heavy calculations again and again, even for the same inputs. This wastes CPU time, impacts performance. So we'll just see a practical example with the calculation of distance, the delivery time with the distance and traffic level. So I will show it to you in the browser itself. So we don't need any editors here. We can see this type of examples in the browser console itself. So there is a function we can see. Function means calculate delivery time on taking of the arguments called distance and traffic level. So we'll write a function. Uh, so we see here I wrote a function called calculate delivery time, which is having a parameters of distance and traffic level. So this will return distance into traffic level. But to show some time how it is been happening with the looping, uh, having some large number of loops happening. So why I have shown to you this looping is when there are some expensive calls are happening, when there is an expensive logic is happening with some multiple loops within arrays or with some numbers. So how this function will be calculates, or how it will take some time, how it will affect the performance on the application. So that's what I kept a for loop here. So we'll just wrote something like result is equal to 0. So this result we kept it for loop, for the sake of for loop only. So that's it, and I just call this function distance is 10 and traffic level is 5. So it is showing like heavy calculation is happening, and you see sometime it has been with this console itself. After that the result came. If I do this one again, the same thing will happen. If I do this uh, multiple times, same thing will happen. Heavy calculation happening, one by one is executing, and then we will get the result. So this is the actual problem when there are some heavy calculations, heavy logics are there. So memoization is needed to store the data somewhere else. So to overcome this type of heavy calculations, this memoization came into the picture in JavaScript. Let's avoid this type of expensive calculations by using memoization. So before going to practically explaining this memoization concept or logically explaining this memoization concept, I want to explain a real life example with this memoization. So we'll see now. So there is a classroom. So in that classroom, there is a teacher and there are some students called Ramu and Somu. So these Ramu and Somu are so crazy. So the student Ramu asking the teacher to get his total marks, and Somu is also following the same. So what's happening is, so the teacher is calculating every time with the total marks, and the teacher is saying to Ramu and Somu many times. So that is without memoization. Teacher calculates the marks each every time, and when the student asks. So if the memoization has been happening in that picture, so what will happen is like the teacher will write the marks in the notebook at once whenever he calculates, and then this Ramu comes and asks, "What are my marks?" He will tell easily, and then Somu comes, he will tell easily. Before he wrote the marks in the book with their names. So what happened here is he is reusing it for the next time. First time he wrote it, he is reusing it every time whenever the student comes and asks. So this is called cache. Like the stored result we call as cache. Okay, we'll see one more expensive function call in the real-time world, like in e-commerce pricing calculation. So the function is like calculating final price with the price tags and the discount or the inputs to this function. So what happens like when the same product pricing is often requested for multiple times, so without memoization, so this calculation will run again and again. So we'll just see, we have already seen one example, so we'll just see one more example based on the e-commerce domain. So uh, I just have a bunch of code, so I'll just copy and paste it. In a price plus tax minus discount. Okay, so now calculate final price with 100 rupees of price and 10 rupees of tax, and then discount is 5 rupees. Suppose we think like, then we put a console like heavy calculation is happening, and then the price is one, I mean the final price is 105, because the total price is 100 and the 10 rupees is the tax and the 5 rupees is the discount price. So 105 is the actual final price calculation. Suppose it was happened again, it will take the same heavy calculation. So when we are using this kind of programming techniques, we call it as like dynamic programming style thinking. So we just need to think it first. So how we can overcome the problems. So memoization is a core idea behind dynamic programming. It solves problems by breaking them into smaller sub problems and storing the results of sub problems so they are not solved again. Simply store it, reuse it, save the time. You see the picture beside this one. Like there is a problem. We divided that problem into sub problems, and the sub problems are cached into a store, and the final result is been came. This is we called as dynamic programming style of thinking. Let us see generic memoize function. So let's build this memoize function that works in any function. I mean that works with any function. This uses closures. The cache lives as long as the returned function exists. So this closures related video, I'll do it again in deeply. Here we have just uh, I mean introduction to this closures with this memoize function, because we are using closures here. So we'll be calling a memoize function, and inside there is a function is being returned with some arguments. There is some logic involved. So this, what is this logic in inside this returning function, we'll see now. I just have been copied, and we'll just put it into the browser. I will explain you line by line. um, so this calculate final price function we have already written, right? So now there is a function memoize which I am been writing in a generic way. So inside that we'll be passing a function. So I am defining a variable called cache with an empty object, and this will return a function, anonymous function, I mean, with some arguments. So these arguments will come from the actual function where we are getting added to the memoize function. We'll see. So I'm just adding a key. This key with the uh, JSON.stringify of arguments. That means whatever the arguments we are passing, I'm just stringifying it to get a property name for the cache object. So leave about this one first. We'll go to the code again. So there is a console.log calculating the result, and then the result will be calculated with the function whatever is being passed in the memoize function, and then the arguments will be passed the actual function call. We will get it. So then we have been adding key to the cache as a, I mean, as a result. That means whatever the result we are getting, that to be added to the one of the property inside cache. Suppose returning the result. But what we are doing before returning the result or before calculating the result itself, we are just checking the result is there with that property inside the cache or not. We are just checking it. If cache is having that key, whatever the arguments we have been passed, I mean it means whatever the input we have been passed is already there in the cache or not, we are checking. We are adding a console returning from the cache. So if it is already there, then we will directly return the cached data. We will not go to execute this lines of code because it is already existing in the cache. So this is where memoization comes. So there is a cache object. We are saving the data with multiple property names where we are getting the arguments as a property names, and then we are saving. So we are checking with the cache if that is already there, and we will return it from the cache. If it is not there, we will calculate, and then it will store into the cache object for the first time, and then the result will come. So this example is looks like a simple example, but uh, whenever there are same inputs are given for an API call, if we think like there is a HTTP call has been happening with the same input in multiple times, so we'll be storing the data in some object with the input what we have been passed, and then whenever the same API call has been called with the same input, we will not go to the call the HTTP request again. because we already have been called and we have the data, so we'll return the same result again. So we'll just see now this memoization function what will do. So we have been defined this memoization function, and then we just do one more operation. So memoized price calculation, I have already calculated, defined this calculate final price, right? So I'll do memoized price calculation with this generic memoize function. So I've been called here, and then right now this calculate final price will take price, tax and the discount, right? So this memoize how we can use it, this memoize function, how we can use it. Suppose there is a calculation to be happen for 1000 rupees price and 100 rupees discount and 50 rupees, uh, 100 rupees tax and 50 rupees as a discount. So I am just entering and calculating result. First time heavy calculation has been happening, so 1050 is the final price given. So second time when I called this function again, I got the result immediately returning from the cache and 1050 has been came. What has happened here is like it gave the result from the cached data object, because the input is same. Suppose I gave the input as 2000, then it will do the calculation again, calculating the result again, heavy calculation is happening, and then it will give the final price, calculated price. We'll wait for the response. So we got the 2050, right? So now I will call the same function with same arguments again. It will give immediately with the same response. uh, Performance has been improved, right? So this is where we have to see this, um, cache is preserved using closures, that's okay. And then this is already we have seen. So same inputs, cache hit, different inputs, new calculation. So this is right now in React, there are many users with this memoization concept. uh, in some of the hooks and React concepts like React.memo, useMemo, use callback, uh, to avoid unnecessary work and to improvise a better performance, better user experience. So, and in Angular also it has been used to reduce the same input type of multiple API calls. So that's a better example which I can say, um, in Angular perspective. So, till now we have seen what are the problems without memoization and what are the improvisations we can do with memorizations. But now we will see when this memoization is not to use. Like what will happen is, with this memoization in a heavy use, like extra memory uses, cache consumes memory. You see, a lot of cache consumes memory, and large cache can be problematic to the app. And second one, so not useful for cheap functions. If a function is already very fast, it will give the result immediately. So then memoization adds unnecessary overhead. That means even though if it is giving a very fast results, and again we are using it with the memoization, it's an overhead, right? Simply, you see. So, and the next one, so large cache problems. Huge cache can lead stale data, memory leaks, and performance issues. This means this cache has been adding again, and it's like huge cache has been added. So to lead stale data. Stale data means it becomes old. So lots of data becomes old. So then it is not useful, and it's an extra memory as well. So that leads to the memory leaks. And then performance issues. So when there is a huge data means app will not load immediately, and then it will not move the screens also, like immediate screen renderings, navigations will not happen. So that's one more thing. Only when repeated calls. So memoization helps only when same inputs are used multiple times. So you see the main main aspirant technique here. So this memoization helps only when the same inputs are being used multiple times. Okay? Use memoization only when it truly improves performance. Finally, I want to summarize the concept of memoization. So this memoization catches result of expensive function calls. If same inputs are provided, cache result is returned, improves performance and reduces unnecessary work. This has been implemented using closures in JavaScript. Memoization has been used heavily in React and many other libraries. These bullet points you can remember for the interview preparations as well. So this is my call to you. Thanks for watching this video. This is Shiva Janala from SaaSFlow signing off.